Hi, I'm Rafael Passos, and this is a submission for the VSoft 2025 Visualization Challenge track. Our focus is on analytical and empirical approaches with visual outputs for the Linux kernel. Understanding the development cycle for Linux is no easy task. Development takes place in different Git repositories, also known as trees, and discussions take place in the mailing lists. This analysis by Jonathan Colbert shows the path patches take to eventually reach the mainline kernel repository from which Linus Torvalds cuts releases. Our team wanted to examine the workload maintainers take to maintain the project. We wanted to investigate the claims we see online about the maintainership health and the project itself. We decided to go beyond analytical work, but also innovate on the methodology used to produce this analysis. One main pillar of our different approach is the Software Heritage Project, the attempt to collect and preserve all open source software ever produced. Their dataset is stored as a graph. They also provide libraries and other tools for researchers to use. We can also use their software to index only the repositories that are interesting for us. However, this wasn't necessary yet. We envision two advantages to this approach. We will be able to run analysis crossing repositories and also joining data from the mailing lists, further expanding this graph. One question we had is how many maintainers are active in the kernel. For this, we also use the maintainers file, the place where the official list of maintainers resides. It is stored in the kernel tree itself. Now I'm going to demonstrate the tool we are working on. This is currently using only the mainline Git repository for the Linux kernel. There are various data points we can choose to see. We can focus on a date period. We can choose how narrow the summation is. For instance, in this view, I can see the number of authors and reviewers for each date, or considering a 2-week summation. In this last view, we can examine the workload in commits for each committer. This seems quite stable. This could mean either the committers aren't seeing an increase in demand, or the limited number of active maintainers is a bottleneck. We believe data from the mailing list could help answer this question. In this case, an author is considered for the sum for 2 weeks. You can also plot metrics in relation to each other. For instance, I can see commits per author. I will now present a few of the analyses we've made. In this one, we can clearly see the peaks of commits before a release. You can also see that the number of committers doesn't change that much. In this one, we try to answer our original question. The green line is the number of maintainers in the maintainers file, plotted for every change made to the file in the Git history. We can actually compare it with how many authors there are in a month, which is who created the commit, how many committers there are, which is the one who applied the commit to the mainline Git repository, and how many reviewers. We can also compare it with the authors that are in the maintainers file and the supporting maintainers that are in the maintainers file. This is every other participant for a commit that is cited under reviewed by or act by or signed off by and the commit message. This is a practice in the commit for the Linux kernel. Like this, we can see that the supporting members are actually growing faster than the maintainers. For us, this is a good sign. In this last view, we can examine the workload in commits for each committer. This seems quite stable. This could mean either the committers aren't seeing an increase in demand, or the limited number of active maintainers is a bottleneck. We believe data from the mailing list could help answer this question. We hope DUKS can help the Linux community and researchers alike. Thank you.